Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Ms. Ledwell, and this video is a review of Section 1 and 2. You can watch it prior to doing your quiz. Let's get started. First, let's recall the Wemyss symbols. The Wemyss symbols include: the first one looks like an exploding bomb, indicates that a material or product is explosive. The second one, which is a flame, indicates that a product is flammable or can catch fire easily. The flame over the circle indicates that a product is an oxidizing substance. In other words, the product can fuel fires. I remember this as underneath the flame is an O for oxidizing. Next, we have a gas cylinder. This means compressed gases, and I remember this because it looks kind of like a propane tank. Then we have corrosive material, indicates the product can cause damage to metals, skin, and eyes. The skull and crossbones indicates a product is toxic and can cause death or harm with exposure. This one here, the top part of a body, means may cause serious health effects. The exclamation mark indicates a product will cause less serious health effects like skin irritation or damage to the ozone layer. The next one with the little upside down fish means may cause damage to aquatic environments. And the three circles means biohazardous infectious materials. This one's for organisms or toxins that can cause diseases in people or animals. You'll see this sometimes if you go to the washroom, there's a sharps container in there on the wall. It's usually orange or yellow, and you'll see the biohazardous symbol on that container. Some notes to remember about binary ionic compounds is that ionic compounds form from the transfer of electrons between a metal and a nonmetal. In ionic compound names and formulas, we always write the cation, the positive ion, first, followed by the anion, the negative ion. Simple anions have names that end in "ide." And ionic compounds are balanced. That means their total positive and negative charges are equal. If a metal can have multiple charges, meaning it's multivalent, make sure you check its charge before naming it, and use Roman numerals for multivalent metals to show their charge. Here's some examples of some binary ionic compounds. We have potassium and bromide, lithium carbide, aluminum phosphide, silver nitride, and calcium oxide. For ionic compounds with polyatomic ions, remember that ionic compounds with polyatomic ions are not binary ionic because they contain at least 3 elements. For example, calcium nitrate contains a polyatomic ion and is not a binary compound. It contains 3 elements. It has calcium, nitrogen, and oxygen. When you refer to the table of polyatomic ions, notice that many of the ions end in ate or ite. Only a few end in ide, like cyanide and hydroxide. This is helpful for recognizing that ionic compounds contain a polyatomic ion. Here's some example of some ionic compounds with polyatomic ions. We have potassium nitrate, lithium carbonate, aluminum phosphate, silver nitrate, and calcium hydroxide. A few things you should remember about binary molecular compounds are that binary molecular compounds are made of 2 nonmetals joined together by covalent bonds. The first element in the formula is named first, using its full elemental name, so we don't change the ending of the first element. The second element is named using its root and adding the suffix "ide." For example, oxygen becomes oxide, nitrogen becomes nitride. Use prefixes mono, di, tri, etc. to indicate the number of atoms of each element. You need to remember the prefixes. For example, CO2 is carbon dioxide. The prefix mono is omitted for the first element. For example, CO is carbon monoxide. We don't say monocarbon monoxide. Prefixes are used for the first element when there is more than one, when there are between 2 and 10. Let's look at a few of the rules for naming compounds. First, you need to look at the compound and say, is this ionic or molecular? If it's ionic, you need to check to see if there's a metal and a nonmetal, or are there complex ions involved. Then you name the ions present. If there's complex ions present, you need to use the chart with the polyatomic ions listed. If there isn't complex ions present, if there's no polyatomic ion, you need to check if there's a multivalent metal. In other words, are there multiple charges possible on the cation? You use the anion charge to determine the charge on the cation. The total positives must equal the total negatives to balance out. And then you use Roman numerals to indicate the ion charge. For molecular compounds, that is, two nonmetals, you check to see if it has a common name. So, for example, you should know methane, ozone, sucrose, hydrogen peroxide, ammonia, water, ethanol, methanol, and acetic acid. These all have common names, and you don't use the IUPAC rules for naming those. If it doesn't have a common name, name the atoms present. There should only be two, and you use those prefixes, mono, di, tri, etc., to indicate how many of each. A couple other things to remember are you don't use a prefix if there is one of the first element. You only use prefix on the first element, 4, 2 to 10. Now let's do some mixed practice, naming and writing formulas for compounds all mixed together. So you're going to pause the video, grab a pencil and some paper, or open up a blank document. Create two separate columns and number each from 1 to 10 because we're going to do two kinds of practice. We're going to do some naming practice and some writing formulas. As each compound or formula on the upcoming slide is revealed, jot down your response. So you may want to pause the video in between the answer being revealed so that you have time to write down your own answer. We will review and discuss the correct answers together as each compound's revealed. After you've got your paper numbered or your document numbered, please resume the video to do our practice. Our first practice set is naming compounds, and these are mixed compounds. So our first chemical formula is SO2. Remember, you're going to do a couple of things before you even write the name of the compound. You're going to look at this and say, is this ionic or molecular? You know it's ionic if it starts with a metal. You know it's molecular if it starts with a nonmetal. So we have a molecular compound here because it starts with a nonmetal. Then you're going to remember your rules for naming molecular compounds. You need to use your prefixes. And the name of this compound is sulfur dioxide. Our next one, PCl5. Think through the same set of steps. Is this molecular or ionic? So look at the first element. If the first element's a metal, it's going to be ionic. If it's a nonmetal, it's going to be molecular. And then use your rules, because this is a molecular compound. Use your rules for molecular compounds. That means your prefixes. And we have phosphorus pentachloride. Next one is NF3, nitrogen trifluoride, LiCl. So now we have a different type of compound. This starts with a metal. It's a metal and a nonmetal, meaning it's an ionic compound. So you're going to use different rules now, no prefixes. Use your rules for naming ionic compounds. And we have lithium chloride, Ca3P2. Again, it starts with a metal and it ends with a nonmetal. So this is an ionic compound. Calcium phosphide, Cus. Remember that copper is one of those multivalent transition metals. So you're going to need to use your Roman numerals with this one. Copper 2 sulfide, NiBr3. Nickel is another multivalent transition metal, so you're going to need to use your Roman numerals in your naming. And we have nickel 3 bromide, CF4. This time we have a molecular compound. And this one is carbon tetrafluoride, MgNO3-2. Now we have something different again. This one contains a polyatomic ion. So you're going to need to look up the NO3, the name of that, on the chart. And this is magnesium nitrate. And last we have S2F10, and this one is disulfur decafluoride. If you're having trouble remembering the rules for naming ionic or molecular compounds, go back and rewatch the instructional videos in the lessons for those. Now let's do some practice writing the formulas for compounds. Our first one is dinitrogen trisulfide. and the formula for that is N2-S3. Next, we have manganese 2-phosphide. Our formula is Mn3P2. Sodium oxide, Na2O. Cobalt 3 oxide, CO2O3. So we're remembering to balance the charges in numbers 2, 3, and 4, which are ionic compounds. Number 5, lithium bromide, another ionic compound, LiBr. Number 6 is sulfur tetrachloride, SCl4. Gold 1 bromide, AuBr. Mercury 2 chloride, HgCl2. Lead 2 chromate, PbCrO4 in brackets 2, and dinitrogen monosulfide, N2S. If you have trouble remembering the rules for writing the formulas for molecular or ionic compounds, go back and rewatch the instructional videos for those lessons. Now it's time to review. In this lesson, you're going to do some mixed naming of compounds and some practice before you complete your quiz on sections 1 and 2. Complete those learning activities in Brightspace.